It took 121 seconds. A more than 30-year-long, almost spotless safety record, erased within minutes as the Aerospatiale BAC Concorde crashed into a hotel just west of Charles de Gaulle Airport in Paris. But what exactly happened, and during the time leading up to the flight? Using the final report, I will now tell you the story of the beginning of the end of the Concorde. Stay tuned. A huge thank you to CuriosityStream for sponsoring this video. Air France flight 4590 was actually a charter flight. It was scheduled to fly from Charles de Gaulle Airport in Paris, France, over towards JFK International in New York, United States. Once they landed in New York, the passengers, who were mainly German but other nationalities as well, were supposed to get onto a cruise ship that would take them down to Ecuador in South America, making this probably a one-in-a-lifetime trip. There was 100 passengers scheduled for the flight and 6 cabin crew and 3 pilots. The aircraft being flown was the legendary Aerospatiale BAC Concorde, one of the most beautiful aircraft ever constructed and a feat of engineering. The Concorde first flew on the 2nd of March 1969, and during its more than 30-year tenure it had never suffered a fatal accident. There are a couple of things that you need to understand technically about the Concorde in order for this story to make sense. If we start with the wing design, we've all seen these beautiful pictures of the Concorde flying with their fantastic delta wing. Now, the reason that the engineers used a delta wing for the Concorde is because a delta wing will work well both in the subsonic, transonic and supersonic speed ranges. The issue with the delta wing though is that in order for it to provide enough lift for takeoff and landing, you need to have both a very high speed and also a quite high angle of attack. Just to give you an example, a Boeing 737 would generally take off at a speed of around 140 to 150 knots. The Concorde, on the other hand, needed about 200 knots. And this is really important because those type of speeds would put an enormous stress on the tires being used on the aircraft. In fact, the Concorde, during its 30 years of operation, had 57 tire bursts. 12 of those had caused structural issues with the aircraft as pieces of tire had been thrown up towards the underside of the wing. And in 6 cases, the wing tanks had actually been penetrated. The most serious of those incidents happened back in 1979, where a Concorde taking off from Washington in the United States had a tire burst during takeoff. Pieces of the tire penetrated the lower part of the wing and one of the wing tanks, causing a small fuel leak, and also it brought damages to the hydraulic system, making it impossible to retract the gear. After that incident, a major investigation was launched into the airworthiness of the Concorde, and a lot of recommendations were made, mainly towards strengthening of the tires being used and the protection of the hydraulic systems in the landing gear. But there was also some evaluations about the risk of fire. But the investigation team felt that the amount of fuel that could escape from a fuel leak caused by tire debris was relatively small, hence the risk of fire was very small as well. Another thing that you need to understand about the Concorde is that it has a quite complicated fuel system consisting of 13 tanks, 12 of which is housed in the wings and the body of the aircraft, and a 13th tank that is situated towards the very back of the body. And that tank is used as a trim tank where the pilots can transfer fuel into or out of depending on where they want the center of gravity of the aircraft to be, which is really important, especially during takeoff. The engines on the Concorde were 4 Olympus twin-spool turbojet engines that were situated towards the back of the delta wing, just outside and slightly behind the main landing gear. They had variable air intakes in order to be able to fly in supersonic flight, and they also had secondary air intakes on the lower side, slightly behind the main air intakes, and those air intakes are actually going to play a quite important role in this story. All of the 4 engines also were equipped with full reheat or afterburner capability, giving the aircraft a further 18% of thrust during the takeoff. The flight departed on the 25th of July 2000, and already from the start there were some problems. Originally, another Concorde was scheduled to do the flight, but they changed over to this individual during the night. And when the dispatcher started doing the planning for the flight, he realized that there was a technical issue with this Concorde, specifically to one of the thrust reversers. Now, it was not a problem that would keep the aircraft on the ground, but it had a performance penalty, and that performance penalty would potentially lead to a need for a fuel stop en route. On top of that, most of the passengers were German citizens and they had flown in from Germany earlier. And there had been some kind of problem in the Air France system when it came to checking in both the passengers and the bags. So a lot of the passengers and the bag were actually not on the passenger manifest when the dispatcher started to do the load sheet. He went with this information to the flight crew when they arrived, and the flight crew said that they would take care of the flight planning from that point. The way they did this was they contacted the engineering department at Air France, asked them if they could possibly fix the thrust reverser. They got a positive response on that, and then they proceeded with the pre-flight. Eventually, the passenger discrepancy was thought to be fixed, but they ended up with 19 more bags on board than what the load manifest would show, giving them a little bit more weight. Around 1400 UTC, so that's 1600 local time in Paris, the flight crew started to do their pre-flight inspections inside of the cockpit. Now, the crew flying consisted of a captain. It was a 54-year-old male with 13,477 hours of total time, of which 317 was flown on the Concorde. The captain was scheduled to be the pilot flying for this flight, and the pilot monitoring was going to be the first officer. He was a 50-year-old male with 10,035 hours and 2,698 hours on the Concorde, and he was also a simulator instructor on the Concorde. Joining them on the flight deck was also a very experienced flight engineer. He was 58 years old, a male, with 12,532 hours of total time and 937 hours on the Concorde. So this was a very experienced flight crew, which was typical for the Air France Concorde crews, which was a very tight little group consisting of only about 30 pilots. As the flight crew starts preparing the aircraft for flight, the engineer comes back up to them, informing the captain that the thrust reverser is now fully functional, which means that they can upload as much fuel as they need in order to fly directly toward New York. And they settle on a final fuel figure of 95 tons. The crew starts discussing that this is going to bring the aircraft up to a weight which is very close to their maximum structural weight for departure. And when they do the calculation of their performance figures, they settle on a V1 speed of 150 knots, a V rotation speed of 198 knots, and a V2, which is the engine out speed of 220 knots. The dispatcher comes in with the final figures for departure, and he tells the crew that he has calculated on a taxi fuel burn of about 2 tons. This is later going to turn out to be way too much, but we'll get to that in a second. At time 14:25, everything is ready for departure. The cabin crew has given cabin secure, all of the passengers are seating down, and the flight crew receives their startup clearance. They start up the Concorde engines in sequence 3, 2, and then 4 and 1. And once the startup sequence is complete, they ask for taxi clearance. The runway used on this day is runway 26 right, which is one of the longest runways in Charles de Gaulle. So the air traffic controller asks the Concorde if they are able to take an intersection takeoff. But given their very high weight, the captain instead asks to get full length departure, runway 26 right. They receive their taxi clearance to start taxiing down taxiway Romeo to holding point, runway 26 right, and at time 14:35 UTC, the aircraft starts moving down towards the holding point. As they're taxiing out now, the crew continues with their pre-departure preparation. As part of that, the first officer realizes that one of the electrical control systems for the rudder keeps jumping out of its primary control system into its backup control system. He comments this to the flight engineer. He says, "Hey, you got the indicators going into green all the time." And the flight engineer responds back to that, yeah, that's true. They discussed this a little bit. They decide to go back into the primary control system anyway, and the flight engineer says that if this problem continues or happens during the takeoff roll, well then we'll just ignore it, because this is a dispatchable fault and it's not going to have any impact on the flight. During this taxi out as well, about 4 minutes prior to departure, they initiate a fuel transfer from fuel tank 11, which is at the very back of the aircraft, towards the feeder tanks in order to get the center of gravity of the aircraft to 54%, which is the sweet spot for takeoff at maximum takeoff weight. This fuel transfer was successfully completed a few minutes prior to departure. At the same time as this is happening, a DC-10 from Continental Airlines is lining up and taking off runway 26 right, the same runway that the Concorde is just about to take off from. During the takeoff roll, a short metal strip about 43 centimeters falls off the right-hand engine of the DC-10. There are no indications in the cockpit about this, there's no warnings, and the crew just continues to fly towards the destination. Because this happens only a few minutes prior to the Concorde departure, there are no runway inspections that could have picked this up. In fact, in France at the time, there was only mandated 2 runway inspections per day. The Concorde is now taxiing and getting closer to the holding position on Romeo for runway 26 right, and the captain does a takeoff briefing. Now this is something that we always tend to do, where we do a little bit of a quick summary of the most important points before we depart. And the captain says, so the takeoff is at maximum takeoff weight, 180 tons 100, which means 4 reheats with maximum N2 of 103 and a failure N2 of 98%. Between 0 and 100 knots, I stop for any oral warning and the tire flash. And the tire flash and the call out is coming from you, right? Between 100 knots and V1, I ignore the gong, I stop for an engine fire, a tire flash and a failure call out. After V1, we will continue on the standard instrument departure, as we just talked about, and will land back on runway 26 right. So this is a pretty standard takeoff briefing from a captain. It outlines what the crew are expected to do in case of a rejected takeoff in the low speed regime, which in this case in the Concorde is between 0 knots and 100 knots. They basically stop for anything. The gong that they're referring to is what would be equivalent to a master caution warning in a Boeing. It's just a oral warning that some kind of failure has occurred. It might not be a critical failure. And then from 100 knots up to V1, they're a little bit more restrictive because they're now in the high speed regime of the takeoff. So from that point, they only stop for engine fire warning, failure warning, and in this case also what they call a tire flash. A tire flash is a warning light that comes on if the system feels a sudden loss of pressure in one of the tires. Now, in the Boeing that I fly, we do not stop for a burst tire above 80 knots. But in the Concorde's case, it has proven to be a much bigger problem, so it's included in one of those critical failures that they will stop for in the high-speed regime. And above V1, they are committed to the takeoff. So all pilots are trained that after V1, if you would reject at that point, you will do a potentially catastrophic runway excursion. So instead, we bring the aircraft into the air, sort out any problem, and in this case, they're discussing coming back to land at a very long runway 26 right again in Paris. But as we're about to learn, the failure that these pilots are about to experience is going to be much more complicated than that. The captain now also asks the flight engineer how much fuel they've used during the taxi, because remember, in the load sheet they had 2 tons calculated. The flight engineer responds with, we've got 800 kilos there. So this would indicate that they're actually using about 1 ton less of taxi fuel, and since they were already at the maximum takeoff weight, using the 2 ton of taxi fuel that they were supposed to use, if they've used 1 ton less, it means that they're now about 800 kilos above maximum takeoff weight. The flight engineer at this point also says, brake temperature is checked at 150. And the captain asks, is it hotter on the left or the right side? The flight engineer says that it's about the same. And that's going to turn out to be a really important statement for the investigation later on. At time 14:42 UTC, the Concorde was cleared to line up and clear for takeoff from runway 26 right. Air traffic control gave them the surface wind of 090 degrees at 8 knots, and the pilot had not calculated with that much tailwind in their performance calculations. If they would have seen that their maximum takeoff weight had now been reduced to 180 tons rather than just above 185 tons. The limiting factor here would have been the Concorde's tire speed, because if you take off with tailwind, it's going to bring you up into a higher ground speed before you get enough airspeed to rotate the aircraft. And in this case, the tire speed would have been too high. The later investigation would show that this didn't have a real impact on what happened to this flight. And I also kind of understand it, being a pilot myself. When you line up, there's a lot of things that's happening at the same time. And if you suddenly get a different wind than what you've calculated for, it's easy to miss that, right? But if you're a pilot out there, it is really important actually to take the time and to really think about the wind that you're getting before you start your takeoff roll. From this point onwards, things are going to happen really, really quickly. And this is where the 121 seconds start. At time 14, 42 and 30 seconds, the captain advances the 4 thrust levels in the cockpit towards takeoff thrust. This causes the 4 mighty Olympus engines to roar into full takeoff thrust with full reheat engaged, and the aircraft starts accelerating down the runway. 24 seconds later, the first officer calls out 100, which is then followed by the flight engineer saying 4 greens. This is indicating that each of the 4 go lights that is associated with each engine is showing that the engine is working normally and that the 4 reheats are engaged. 6 seconds later, the first officer calls out V1, and there's now no return from this takeoff. This is about 35 seconds into this flight. At time 14:43 and 9 seconds, a slight yaw to the left is noted on the flight data recorder. This yaw was not caused by any rudder movement, and at this point, when the aircraft passed about 1700 meters of the runway, they also found pieces of the water deflector from the left-hand main gear. So this probably represented the time when the Concorde rolled over that metal strip that was left behind by the DC-10 that had departed earlier. Within half a second, noise is recorded on the cockpit voice recorder, and that's likely coming from the explosion of one of the tires on the left main gear bogie. The reason that the investigators thought so was because at this point on the runway they could find the metal strip and also pieces of tire debris. 1 second later, the aircraft has accelerated to a speed of 178 knots, and at this point, that's about 1810 meters into the takeoff, a change of noise is heard in the cockpit. What has probably happened here is that pieces of the exploded tire have been thrown up towards the underside of the left-hand wing in the area of where fuel tank number 5 is situated. Now those pieces have impacted the wing with such a force that it actually buckled the underside of the wing inwards, and the area around that buckle a little bit outwards, causing an enormous pressure wave inside of the tank. And since this tank was at this moment completely full, that pressure wave didn't have anywhere to go except pushing further on the area of the tank next to where this piece impacted, causing a rupture outwards of the fuel tank. And the reason that the investigators think that this is what happened is because they found pieces of the number 5 fuel tanks at this position on the runway, but the pieces indicated that the rupture had happened from inside of the fuel tank and not from the outside. The change of noise that can be heard on the voice recorder is most likely coming from the fact that several dozens liters of fuel is now gushing out through this hole from the number 5 fuel tank, and it has gotten into contact with something that caused it to ignite. What caused the fire to ignite and actually sustain itself is something that was greatly discussed in the subsequent investigation as well. But most likely, the tire, when it exploded, caused a breakage of some electrical wires in the left gear strut. Now, those broken wires then caused arcing that ignited the flame, and the fact that the landing gear was still extended meant that behind the landing gear there was a turbulence zone that allowed the flame to stabilize and maintain itself without being blown out by the airstream. What happens now is that the aircraft starts veering towards the left of the runway. The captain counteracts with right rudder to maintain the descent line, and this is not because the engines are starting to fail, at least not at this point. Instead, it is likely that this veering moment is coming from the damage made to the left-hand tires, and also because of the aerodynamic drag that the flame is producing behind the aircraft. 2 seconds later, the aircraft is starting to lose thrust on both engine number 1 and 2, so both engines on the left-hand side. In the case of the number 1 engine, it's because it's ingesting a lot of debris from the broken tires, or rubber, things like that, and also quite a bit of hot gases. And in the case of engine number 2, which is the engine that's closest to the landing gear, it is because of ingestion of hot gases. As an engine ingests these gases, it changes the pressure inside of the compressor, and it can lead to compressor stalls, which is what's happening here. So the engine is basically choking on the gases. The first officer now calls out, "Watch out!" quickly followed by the flight engineer calling the exact same thing, "Watch out." And this is likely because the 2 go lights of engine 1 and 2 would have extinguished at this point, as they are stalling and not producing the thrust that they're supposed to do. The aircraft is now at a speed of 187 knots, still 8 knots below the rotation speed. But because both engine 1 and 2 have essentially failed at this point, engine number 1 is slowly recovering, but engine number 2 is back at idle thrust. The aircraft is starting to yaw very, very hard towards the left. The captain is counteracting this, but the aircraft is still starting to slightly veer off the center line. We don't know why the captain decides to start rotating at this point. Maybe it is because he feels that he is about to exit the runway. Maybe it is to avoid other traffic that he sees further down on the taxiway. We don't know this. But the fact is that he does start to rotate the aircraft, and he rotates slower than he would normally, probably indicating that he's aware that the speed is not high enough. As the aircraft is rotating, the flight engineer calls out something that sounds like "stop," but it wasn't clear on the voice recorder. But only a second later, he calls out "engine failure, engine number 2." And he's calling only engine failure on engine number 2 because engine number 1 is actually starting to recover from those initial stalls. But as the aircraft continues to rotate and the angle of the nose comes up higher and higher, the airflow changes around the wings, probably causing these hot gases once again to be ingested into both engine number 1 and engine number 2, probably using those secondary engine inlets that we talked about before. And this causes further stalls, which once again reduces the thrust back to near idle on both of these engines. At this point, the first engine fire alarm also can be heard in the cockpit, and the flight engineer responds to that with calling "shut down engine number 2," and the captain responds with "engine fire procedure." As this is happening, the air traffic controller can see this all happening out from his viewpoint in the control tower, and he calls out, "Air France 4590, you have flames trailing behind you." The first officer reads this back. The flight engineer is now doing the engine fire procedure, which means that he is reducing the thrust lever back to idle on engine number 2, and he is also pulling and rotating the engine fire handle. This momentarily removes the fire alarm, as the extinguisher is likely cooling down the engine, but it's soon coming back again because of the fact that the fire is not actually in the engine, it's outside, and the engine fire circuit is just feeling the increase in temperature from the immense fire that is burning outside. While this is happening, and remember, everything that we've covered so far has only taken a few seconds, there's another radio call from an unknown aircraft somewhere on the airport. And the pilot there says on the radio, "It's really burning, eh? And it's burning, and I'm not sure it's coming from the engine," which is going to be very helpful evidence later on to the investigators. The Concorde is now finally airborne, and just before it became airborne, it ran over a few edge lights on the left-hand side of the runway. And the crew now faces the next problem, which is their airspeed. Because they rotated at a slightly lower speed than they normally should have rotated with, they're now maintaining a speed of 200 knots, while their engine out climb speed is 220. This means that with that airspeed, they won't be able to climb or even maintain altitude. And the first officer points it out by calling "speed, speed" several times. Engine number 1 is now recovering slightly, but it's heavily damaged and will never get back up to full thrust again. Engine number 2 has been shut down through the engine fire procedure that the flight engineer has just completed. And engine number 3 and 4 has gone into something called a contingency mode, which is where they are producing as much thrust as they possibly can in order to counteract the loss of thrust on one or two of the other engines. The Concorde is at an altitude of 100 feet radio with a speed of 200 knots, and they're climbing with about 750 feet per minute. And at this point, air traffic control calls them and says, Air France 4590, you have large flames trailing behind you and you have priority to return back to the airfield. The first officer reads this back, and as he's done so, the flight engineer reminds him to take the gear up. Now, the first officer responds initially no to that, and that's likely because he knows that as a procedure, if there is an indication of a damage to the landing gear, the Concorde is not supposed to retract the gear. But then the captain breaks in and gives a direct order to retract the gear. The first officer tries, but it is evident from the cockpit voice recorder that he is unable to do so. He just cannot seem to get the gear up. The reason for this is likely because of the damage that has been caused by the tire explosion. It might have damaged the landing gear door on the left-hand side, and because of the sequence that the landing gear retraction is supposed to follow, if the landing gear door does not move when it's being commanded to do so, the landing gear will stay out. The captain now turns over to the flight engineer and asks him, are you shutting down engine number 2? And the flight engineer responds with, yes, it is shut down. The first officer again calls out airspeed, speed, and then the gear is not retracting. At time 14:43 and 55 seconds, the first indications of an uncommanded roll can be seen on the flight data recorder. This roll likely is caused by the fact that the fire has now been burning for a while and it's starting to melt the inboard elevon on the left-hand side, which is causing flight control problems. Now the captain is trying to counteract this roll, and meanwhile that is happening, the nose of the aircraft is pitching up more and more and its angle of attack is constantly increasing. The first officer is listening out to the ATC frequency, and he can hear how Charles de Gaulle Tower is talking to the fire leader, who is telling the fire leader that the Concorde is likely going to return back for straight-in landing on the opposite runway. In response to that, he calls out, Le Bourget, and we are going to try for Le Bourget. The engine fire alarm is now back again in the cockpit, and the engine number 1 is surging once again, removing all of the remaining thrust on that side of the aircraft. This further causes the aircraft to roll over to the left, and it gets into, at the worst point, a roll angle of 113 degrees to the left. The GPWS warning system is now sounding in the cockpit as well, saying "Poop, poop, pull up," and as that is happening, there are indications that the thrust is being moved back on the remaining engines, 3 and 4. This is likely to try to counteract the roll and get the aircraft over to wings level in order to be able to get it to continue to fly. Unfortunately, it is just too late. Only seconds later, at time 14:44 and 31 seconds, the Concorde crashes into a hotel in Gonesse, just west of Charles de Gaulle Airport. As it does so, all 109 people on board the Concorde perishes, together with 4 people in the hotel on the ground. This was an unspeakable tragedy, and start on the air accident investigation started immediately at the crash site. When the investigators started to go through all of the pieces that was left behind the crash, they very quickly found the left landing gear bogie. And when they examined the landing gear bogie, they realized that there was a crucial spacer missing. The function of that spacer was to keep the alignment of the tires on the landing gear bogie, and without that spacer in place, the bogie could actually start to wobble up to 3 degrees in any direction. Now, could that have actually had an impact on the accident sequence? And also, was there anything that the pilots could have done in order to avoid this accident from happening? I'm going to tell you all about what the accident investigation team found out just after this short message from my supporting sponsors. I want to take this opportunity right now to just thank the sponsor of this episode, which is CuriosityStream. And I love to have them on as sponsors because I know that you guys are watching this episode because you, just like me, love nerding out into a great documentary or a non-fictional story. And that's exactly what CuriosityStream is all about. They are a subscription streaming service with thousands of high-quality non-fictional stories or documentaries from some of the best filmmakers in the world. Now, I am watching right now something called Hurricane: The Anatomy. It's a mini-series, and I had no idea that I knew so little about hurricanes. If this sounds interesting to you, then go to curiositystream.com/mentorpilot, use the coupon code MentorPilot, and that will give you a whopping 25% off the yearly fee, and that comes down to, wait for it, $14.99 per year, which is just insanely cheap for what you get. So if that sounds interesting, go down, click the link, support me by supporting my sponsors, and enjoy. The first thing that the air accident investigation team started doing when they found out about the missing spacer was trying to find it, because maybe it was somewhere on the crash site. But quite quickly they actually found the spacer in an Air France workshop where the Concorde had undergone some maintenance to that landing gear bogie just a few days earlier. This was a very serious lapse on behalf of Air France, and the investigation team now needed to understand whether or not this missing spacer could have actually caused or aggravated the accident. And the way they went about doing this was they had a look at the performance data of the Concorde. If the landing gear bogie would have started to skew during the takeoff run, or indeed during the taxi out, you would be able to see that on the way that the aircraft accelerated during the takeoff. And also remember how the crew talked about the brake temperature before the takeoff and the fact that it was equal on both sides. Well, that was the first real clue that the landing gear bogie was actually lined well, at least during the taxi out, because if it would have been skewed, that would have had an indication on the brake temperatures, potentially higher on the left-hand side. During the takeoff roll, the investigators had a look at the rudder pedal movement of the pilots to see if there had been some kind of pull towards either direction. But they found nothing. And on top of that, the data from the performance manual of the Concorde very closely matched the actual performance of the aircraft during the takeoff roll. And that would indicate that at least during the takeoff roll initially, before they ran over the metal strip, there was no extra drag coming from the left wheel bogie. So the alignment seems to have been good all the way up until the aircraft crossed over that metal strip and the tire exploded. Together, these data indicate that even though the missing spacer was a major lapse on behalf of Air France, it still didn't have any real impact on the accident sequence. The investigation team now turned their eyes towards Continental Airlines and the DC-10 from which the metal strip had fallen. And when they visited Continental Airlines and they went through the maintenance history of this DC-10, they recognized that this support metal strip had actually been replaced not once but twice within the previous 2 months. And when they looked at it, they realized that the metal strip in itself had not been manufactured according to the engine manufacturer instructions. It had also been drilled 37 times rather than the 12 times that was stipulated by the engine manufacturer. And the metal strip next to it was actually a little bit too long. And that was what was causing this metal strip to be constantly wore down, and probably also the reason that it fell off in the first place. These findings led to quite a lot of litigation and legal issues between the French authorities and Continental Airlines, but we're not going to get into that in this video. Instead, let's have a look at how the pilots performed during these 121 seconds. The air accident investigation team very quickly realized that the pilots had never been trained for a scenario like this, where they would lose both engines on one side together with a huge fuel leak and on top of that a fire. Since the aircraft had accelerated past their decision speed of V1 when they ran over the metal strip and the tire exploded, the crew was essentially committed to the takeoff from that point. If they would have decided to reject the takeoff, it is highly likely that the aircraft would have had a high-speed runway overrun, which would have led to a landing gear collapse, and that together with the already burning fire would have in all probability led to a complete loss of the aircraft. So the fact that they continued the takeoff and brought the aircraft into the air was completely understandable. Once they were in the air, they effectively lacked enough thrust to get the aircraft to accelerate up to any sustainable climb speed or climb, given that they couldn't retract the gear. And the fact that they couldn't retract the gear was probably what was maintaining the flame outside as well. So even if the pilots would have been able to keep the aircraft wings level and airborne, the sustained fire would have eventually started to eat through both the flight controls on the left-hand side and the aircraft structure, leading to the disaster. So effectively, the investigators said that there was very little to nothing that this crew could have done differently in order to avoid this accident from happening. So in the end, the air accident investigation team concluded that a single burst tire, something that had happened to the Concorde before many times and was likely to potentially happen again, was the cause of this catastrophic and unreversible tragedy. And because of that conclusion, the airworthiness certificate of the Concorde was almost immediately withdrawn until some serious improvements could be done to the structure. These improvements included things like Kevlar lining inside of the fuel tanks to make sure that even if a tire would burst, it wouldn't have these catastrophic consequences. It also included the protection and partial rewiring of electrical wiring inside of the landing gear strut and the wheel well bay. And on top of that, the aircraft needed to be fitted with new burst-resistant NCG Michelin tires, and there were also some other minor improvements that needed to be done to the aircraft. All of this led to the Concorde being grounded for more than a year, and just before it was scheduled to get back into service, the horrible terrorist attacks of 9/11 happened in New York. That had a huge influence on the aviation business worldwide, so it was to become the beginning of the end of the Concorde era. The Concorde continued to fly for another approximately 2 years until British Airways, as the last remaining operator, retired the last Concorde on the 24th of October 2003, marking the end, at least for now, for passenger supersonic flight. I also want to mention here that the UK Air Accident Investigation team had some serious issues with the way that they had been treated by the French investigation team in this effort. The UK team said that they had been denied access to crucial bits and parts of the information. They hadn't been able to investigate some of the debris that was found on the runway until much, much later, and many other points like this. And this is all outlined in an appendix to the final report. Now, if you guys want to see an absolutely hair-raising story about two pilots who pushed their aircraft to its absolute limits during a positioning flights in the US, which had some really serious consequences, well then check out this video up here. Or you can binge watch this entire video series about air crash investigation using this playlist up here. Have an absolutely fantastic day. And if you guys want to support me and support the work that I do with the channel, well then consider becoming a Patreon. I have weekly hangouts with my Patreon crew. I love doing that, and I hope to see you in one of those hangouts next time. Bye bye.